To identify the LCM, you're basically using that to make the denominators the same. You're going to do all on this worksheet. So on number 2, we have x and x squared. So to find the LCM, we're going to use cake method. So these both divide by x. So x divided by x is 1, and x squared divided by x is x. To find our LCM, we're going to multiply what we divided out times our last row. So 1 times x is x squared, and that is our least common multiple. On number 4, we have 10x and 4y. So we're going to go ahead and write those out, set up our cake method. These both divide by 2 because they're both even numbers. So 10x divided by 2 is 5x. 4y divided by 2 is 2y. So 5x times 2y times 2 is 20 times x times y. Okay, the last one, number 6. Notice that there is nothing in common with either of these. So when that is the case, our least common multiple is just the product of the two things. So we can either do FOIL or box method to find the product. Let's go ahead and do box today. So when you fill in your box, you have 2x squared plus 6x minus 1x minus 3. Combine like terms. Your answer is 2x squared plus 5x minus 3. On this next slide, all it is just the steps written out. To set up our rational expressions for adding and subtracting fractions, we're first going to find the LCM of the denominators, doing the same thing we did on the previous examples. We're going to multiply the first fraction by 1 and multiply the second fraction by 1. These are special ones where the denominator times that special one is going to give you the LCM at the bottom. Now the fractions will have, once the fractions are the same, we're done setting up the problem. So let's try these examples right here. So first we're going to find the LCM. Neither of these have anything in common, so we're just going to multiply them together. So 2 times a squared is 2a squared. 2 times 2a is 4a. And then 2 times negative 8 is negative 16. So from there, we're going to set it up. Let's multiply these by 2. Those are our complement to get the LCM. And then the complement of the first fraction is a squared plus 2a minus 8. So once we multiply those out, we have 3a to the third power plus 6a squared minus 24a. And that is all over our LCM, 2a squared plus 4a minus 16. So that's our first fraction. Now let's write our second one. We're going to multiply these by 2. So we have 2a minus 2 at the top in our numerator. And then our denominator should be the same thing as our LCM. And that's our answer. That is our setup form. We only need to set it up for this page. Okay, on the second one, the next one, we can go ahead and use our cake method. So let's set that up. We write our two denominators. And we see what both of them divide by. Looks like they both divide by 3n. So 3n divided by 3n is 1. 3n squared divided by 3n is n. And then negative 6n divided by 3n is 2. So our LCM would be 3n times 1 times n minus 2. And when you multiply that out, you just get 3n squared minus 6n. Okay, go ahead, pause the video, see if you can figure out what the two complements are. Okay, the complements for the first fraction is n minus 2, because n minus 2 times 3n gives you the LCM. The second fraction's complement is only 1, so you're going to multiply those by 1. So once you multiply those out, 3 times n is 3n. 3 times negative 2 is negative 6. So we have 3n minus 6. And at the bottom, we just have our 3n squared minus 6n. Plus our original second fraction, 2 over 3n squared minus 6n. And that is our setup form for that. Okay, on the next one, we have in the denominators two things that look completely different. So to find our LCM, we're just going to multiply them together. So let's go ahead and use box method. Go ahead and set up your box. M squared, 2m, negative 4m, and then minus 8. And then we multiply each of those by 6. Now, that's actually not needed for this since we're only talking about the denominator right now. So for our LCM, let's go ahead and leave it in the factored form. 6m plus 2 and m minus 4. Finding the complements are easy on these. You just multiply by the other denominator. So it will look like this. The 6m plus 12 came from multiplying the 6 into both of these terms. So when we write that out, we have 5m minus 20 all over our LCM, and then minus 36m squared plus 72m all over our LCM. And that would be our setup form. On the last one, we could go ahead and set up our cake, and they both are going to divide by 2. So after you divide those, you have 2b squared and 1. So our LCM is going to be 2b squared times 1 times 2, which is just 4b squared. From there, we're going to multiply by our complements. Okay, you have 2b squared. Once you get that, go ahead and multiply those out to get this.